In this video, I want to talk a little bit about what is a type 1 and a type 2 error within a test of significance. So just to sort of recap really quickly, remember in a significance test, there's always two conclusions, and kind of just reiterating the general procedure of a significance test. It's like, well, we want to determine, is our sample, how far away is it from the mean, and is that far enough? It's kind of like, well, we want to calculate what's the test statistic given the formula x bar minus mu naught divided by the standard deviation of the sampling distribution. And then once we've found the test statistic, we calculate, okay, what's the associated p-value for that result? And then assuming we were given an alpha, a significance level, there's always two conclusions, right? We have if our p-value is less than alpha, we say that it is statistically significant and we reject the null hypothesis. And the other case would be if the p-value we obtain is greater than alpha, we fail to get statistically significant results and we fail to reject the null. But I wanted you to notice that there's only those two conclusions, and it's always based on the p-value. But essentially, the type 1 and type 2 error describe what happens when we're wrong. Because again, alphas, there's always like a significance level of, say, 1% or 5%, which we could be wrong at the end of the day. Because say we get a p-value like 0.02, and that's less than 0.05, we say we reject the null hypothesis and we conclude, okay, that is not correct. The mean is not actually 550, or the mean is not 70%, or whatever from the examples that we've looked at. But again, there is a 2% chance we're wrong, and that's what we refer to as a type 1 error. If we reject h sub 0 when in fact h sub 0 is true. And again, there's always the level of significance, alpha, which is like how comfortable with being wrong are we going to be. And the type 1 error chance of happening is always alpha. It's kind of like that's set to be, whatever your significance level would be. Also, you might be wondering, how do I actually know if I encounter a type 1 or type 2 error? Well, you wouldn't unless you actually knew the real mean. So when you're running a significance test, you don't really know if these errors are occurring. You just have to kind of live with them and be aware that there's a chance that it could happen. Now, there's also what's called a type 2 error. So in the case that, let's say we got a p-value of 0.17, which is greater than 0.05, again, we would fail to reject H0. Notice that we don't conclude that the mean is equal to 550 or whatever, like in some of the examples we looked at. But essentially, we're forming a conclusion based on a 17% chance. Again, there's still a pretty good chance that the mean is different, but we're not comfortable enough with that result being wrong. And a type 2 error occurs that when we fail to reject H0, but it was actually something else instead. Like again, putting it in the case of the GMAT scores, mu equal to 550, the researcher thought that the mean value of her student scores was lower than 550. And let's say she obtained a score of 539 or whatever in those cases. And, we looked at examples where we failed to reject H null, and we looked at examples where we did reject H sub 0. But in the case where we failed to reject H0, but let's say that in actuality, the mean of her students was 532. That is obviously different. And it just, there's, again, sampling error. The problem is there's random chance always involved. So when we form a conclusion, we are not always right. A type 1 error occurs when we do reject the null hypothesis, but it was actually true to begin with. And a type 2 error occurs when we fail to reject the null, in the case when p is greater than alpha, but the null was actually true all along. And I think this chart really helps sum it up. Like, we come up with a correct conclusion most of the time based on the significance level. Like, if we were to reject H sub 0, and if the alternative hypothesis was actually true, we would get a correct conclusion, and that would always happen. Again, it always depends on alpha, but let's say alpha was 0.05. Type 1 error would only happen 5% of the time, and a correct conclusion would happen the rest of the time. Now, in a completely different case, if we come up with a correct conclusion from, if we fail to reject the null and the null was actually true, again, we would get a correct conclusion. However, there's a different probability associated with this, and it has to do with the calculation on power, which I mentioned before is not something you need to worry about. But essentially, it all has to do with this sort of logic, and this chart can help you figure out what type of error you're dealing with should you be asked.